Hello and welcome back. Today, we will be understanding how to implement the false position method that we learned in the course of numerical computing in Python. First of all, in order to implement the method, we must understand how does it work. The false position method in Python. Here we are given a function. In the function, we have x squared minus x minus 4, and we are to find out the root of this function. We have three variables a, b, and c, where a is the upper boundary of the root while b is the lower boundary of the root. We are to first check whether the function of a multiplied by the function of b equals to be greater than 0. If that is the case, our method cannot be carried out, and this message will be displayed in our program. After that, we are to find out the variable c. The formula of finding out c is a minus the function of a multiplied by a b minus a divided by the function of b minus the function of a. This is the formula to find out c. Once we have found out c, we are to find out whether the function of a multiplied by the function of c equals to be lesser than 0. If that is the case, we switch the places of b and c. However, if that is not the case, we switch the places of a and c. Now, let's move to Python and implement this program in the IDE. Okay, first of all, let's define a method. Let's name it def false plus, and let's pass in 4 arguments. First of all, the first argument would be our function. The second argument would be the value of a. The third argument would be the value of b. And the fourth argument would be the number of iterations that the user wants to be performed. Now, Python wouldn't really understand the function that we have given it. So, in order for it to understand and return its value, let's define a function. Let's name it f of x. Now, let's create a variable named f. Now, we need this variable to store the value of the function after it has been evaluated. So, let's put in eval func, because that's a function name, and let's make it return f. So now we have a function within a function which returns the evaluated value of our main function. Now, let's put in our first if statement. Here, we were to check whether the function of a multiplied by the function of b is equal to be greater than 0. And if that was the case, we were to output method can't be carried out. However, if that is not the case, we put in an else statement here, and now we need our program to run until we reach the number of iterations desired by the user here in the function. So what do we need? We need a variable that serves as a purpose for iteration. Let's name that variable n, and let's give it a value of 0 so that it begins from 0 till the number of iterations. So in order to do that, we put in a while loop while n is lesser than equals to the number of iterations, and which is itr. Lovely. Our next step is to find out the value of c. How do we do that? Well, the formula is simple. C equals to be a minus bracket open function of a multiplied bracket open again b minus a bracket close divided by bracket open function of b minus the function of a bracket close again, bracket close again, and bracket close once again. Here we have our c. Now we have found out c, but we have to keep updating it so that we get to the root. How do we do that? If statement, simple, like we revised before. You put in if the function of a multiplied by the function of c equals to b lesser than 0. If that is the case, we swap b and c. However, if that is not the case, we swap a and c together. Now, since we have to keep iterating until we reach the desired number of iterations, we have to keep updating our n. So we increment n by 1. So n is equals to n plus 1. Now, let's just print out the output of every root that this program calculates. So let's do that. So just like this. Print. Let's do it in a formatted string because that is easier to do so and clearer. F root of equation equals to the function, and that is equals to c. Lovely. Now here our program will keep printing every value of c that it comes through. Here our program is completed. Now let's call the method. Right. False pass. We pass through x cubed minus x minus 4. Right. Let's give the value of a to be 1, the value of b to be 2, and the number of iterations to be 5. And it works wonderfully. Thank you so much for watching, and hope to see you in the next one.